Describe a simple method the student can use in order to check that the lens has a focal length of 10 centimeter. You may use a diagram in your answer. Rays of light coming from distant objects, and then place the screen at 10 centimeter to check whether the focused image of the rays through the rays is obtained or not. Now I'm also drawing a diagram here. So this is the diagram that we can use to demonstrate this experiment. Welcome to this tutorial. I'm solving question number 1 of paper 4-2 October-November exam series of 2015. The question is related to GCSE O-Level Physics 5054, and it is related to the topic of light and optics or lenses of the syllabus. In this question, the examiner says a student performs an experiment to obtain an accurate value for the focal length of a converging lens. His school has lenses with focal lengths 10 centimeter and 15 centimeter. So these are the two types of lenses with two different focal lengths available. The student is given a lens from a packet labeled focal length 10 centimeter. So this is what is written on the packet. Describe a simple method the student can use in order to check that the lens has a focal length of 10 centimeter. You may use a diagram in your answer. So the method is very simple. What the student should do is that he or she should be using the rays of light coming from distant objects, and then place the screen at 10 centimeter to check whether the focused image of the rays through the rays is obtained or not. So if the focused image or the clear image is obtained at a distance of 10 centimeter, then it would mean that this is the focal length of the lens. So I'm writing rays of light coming from the distant object should be refracted through the lens, and screen should be placed at 10 centimeter to obtain a focused image. So if the image is sharp, then the focal length is 10 centimeter. Otherwise, the screen could be adjusted to find the real length or the actual length of the lens. Now, I'm also drawing a diagram here. So this is the diagram that we can use to demonstrate this experiment. We have used a lens here, a converging lens, and we have placed a screen at a distance of 10 centimeter. So the parallel rays are coming from a distant object, and they are coming parallel to each other. And after being refracted from the lens, they would be converged to a single point on the screen, and the most sharp image and the focused image would be obtained if the focal length of the lens is 10 centimeter, and the screen is also placed at 10 centimeter. So this is how the focal length of an object could be found using the simple experiment. The next part says the student then uses apparatus in figure 1.1 to obtain accurate value for the focal length f of the lens. The student places the lens a measured distance u from the illuminated object. So this is the illuminated object. He then adjusts the position of the screen until a clear focused image is seen on the screen. He measures the distance d from the object to the focused image on the screen. Now the first task is on figure 1.1, mark and label the lengths u and d. Now u was the distance which was from the illuminated object to the lens. So this distance is u, and there was another distance from the object to the focused image, and focused image would be formed on the screen, and this distance would be d. The distance u is set at 85 centimeters, and the student measures the distance d. He repeats the experiment and obtains the following values in centimeter for d. So he obtains 5 values. Calculate d average, the average value of d. Give your answer to 3 significant figures, because we can see that in the raw data the distances are also given in 3 significant figures. To find the average, we are going to add these values and then divide them by 5. So the average value comes out to be 96.3, and this would be written in the answer space. State one way in which the student can ensure that each measurement of D is accurate. So one way of doing it is to avoid the parallax error while taking the readings. The next part says the student repeats the experiment for a range of values of D and obtains a value of D average each time. The results are recorded in figure 1.2. On figure 1.2, add your value of D average for U equal to 85 centimeter from B part 3. So it was 96.3 centimeters. Now the next part says figure 1.3. On figure 1.3, plot the graph of D average in centimeters on the y-axis against U in centimeters on the x-axis. So the quantity on the y-axis is D average in centimeters, and the quantity on x-axis is U measured in centimeters. Start your axis from 0, 30. So it is already written here that the x-axis value should start from 0 and the y-axis value should start from 30. The graph shows D average has a minimum value. Draw the smooth curve of best fit. Now we can see that the minimum value for U here is 12 centimeter and the maximum value is 85. So we have to take a scale accordingly for U, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 markings here. So the scale I'm using here on x-axis is 5 small boxes would represent 10 centimeters. So according to this scale, the values should be marked here 10. So these are the values on the x-axis. Now for y-axis, we can see that the smallest value we have is 40.5 and the largest one we have is 96.3. And on the graph, we have 14 divisions, 5 small boxes on y-axis representing 5 centimeters. So now the values would be marked like this. So now I have done two things. First is I've marked the axis, the quantities on each axis, and then I've used a scale according to the given value and written all the numbers on the x-axis and y-axis which are to be used for plotting the points. The next thing I'm going to do is that I'm going to plot all these points on the graph. So now I have plotted all the points. I'm going to make a smooth curve of best fit with this data. So this is the smooth curve that I've made using all the points which were plotted on the graph. Now the next part says use your graph to find the minimum value of D average. So the minimum value of D average that we get from the graph is 40. So I'm writing 40 centimeters. The next part says the value of U when D average is minimum. Now, so the value against the minimum average value of D that we get for U is 22 centimeters here. So this point is representing a value of 22, and this would be recorded in the answer space as well. So I'm writing 22 centimeters here. The last part of the question says, theory shows that the minimum value of D average is when D average is 4 times the focal length of the lens and when U minimum is twice the focal length. Calculate D average upon 4 and U minimum upon 2 from the values you have given in C3. Comment on your answers. So here I have calculated D average upon 4, which gives an answer of 10 centimeter, and U minimum upon 2, which gives an answer of 11 centimeter. Both of them are representing the focal length of the lens, and we can see that they are almost approximately the same values within the experimental range of error. So I've written an argument, both values are almost the same and represent the focal length of the lens. So the question ends here with this answer.